Can everyone access the link, okay? If you haven't joined the Science Party Facebook discussion page already, anyone? Are you guys in the Facebook discussion group?
I didn't.
Yeah. Check out the Facebook discussion group. You can find the link. Just check if it's the broadcast is working all right. And then if you like it, then hashtag Science Party Oz, right? Share it on Twitter or whatever you guys use these days, you youngins. Hey, Peter, how are you, mate?
Good.
All right. Thank you all for coming tonight. This is a pretty good turnout for the Science Party. Lots of eager people who are interested in what we're doing. We have a very exciting year ahead of us, but that's only half the story. We have a very exciting future ahead of us, and tonight we're going to have Peter and Now talk about where technology is headed and how it's changing how we interact with technology. So we're going to have two talks by Peter and Miao, and then afterwards I'm going to give a little bit of a talk about what Science Party is, and then we can have a discussion about some of the things that are coming up in the near future. So I guess we'll start off. Peter, would you like to get going first? Yeah.
All right.
Peter Singh.
Hey. Guys. Thanks for coming all the way. All right, we go from here. Cool. All right. Impact of accelerating change and the future of humanity. Pretty bold. I don't know if I can live up to that title. So yeah, thanks for coming along. If you guys, some housekeeping, if you need the bathrooms, it's just turn right once you're out the corridor. All the way at the end, it's a bit of a far walk, so try to go before it's too late. We usually host a lot of innovation stuff here. As part of Deloitte, we're trying to do this Deloitte Startup Network, and we're trying to bring in all the things that are sort of innovation-y, startup-y, altruistic-y, right? So we got Peter Slattery here, we've got James and Miao, all the biohackers, we've got the Science Party guys all up here. So yeah, look out for the news contents coming out of the Science Party or the Biofantry guys, or the transhumanists, which I'm helping to organize some of the meetups, and more will come along this way. I think we got Future Day coming up as well, which is a day for the futurists to talk about, future of humanity. So stuff like this. So if you like what you see today, we have an event on the 1st of March. All right. So I'll go straight up. So hands up if you guys heard of this thing called Ibm Watson. Yeah, that's pretty good. Good marketing team from IBM, right? So Watson was this thing that IBM came up with to beat lots of champions on the game show host called Jeopardy. And since then, they've tried to monetize it. They've tried to, figure out how to best make the most use cases out of it. So, Deloitte and a bunch of other guys have been trying to figure out how do we, automate a lot of the processes and at the same time provide some insights. But let me just play this video for you to check out what it's all about.
Technology has helped us go further, go faster, go to the moon, solve problems previous generations couldn't imagine. But can technology think? Watson can. IBM Watson is a technology unlike any that's come before. Because rather than force humans to think like a computer, Watson interacts with humans on human terms. Watson can read and understand natural language, like the tweets, texts, articles, studies, and reports that make up as much as 80% of the data in the world. A simple internet search can't do that. When asked a question, Watson generates a hypothesis and comes up with both a response and a level of confidence. And then Watson shows you the steps it took to get to that response. In a way, Watson is reasoning. You don't program Watson, you work with Watson. And through your interactions with it, it learns, just like we do. Every experience you give it makes it smarter and faster. But in addition to learning, Watson can also teach. A new generation of doctors are helping Watson learn the language of medicine. In turn, Watson is helping teach doctors by providing possible treatment options. Watson is learning the language of finance to help investment advisors recommend the best way to plan for retirement. The IBM Watson Engagement Advisor can react to a caller's questions and help operators find the right answers faster. The IBM Watson Discovery Advisor helps researchers uncover patterns that are hiding in mountains of data and then share these new insights with colleagues. With Watson Analytics, you can ask Watson a question, and Watson can show you what the data means in a way that's easy for anyone to understand and share. The IBM Watson Developers Cloud offers software vendors and developers the technology and tools they need to take advantage of Watson's cognitive power. Accessible on the cloud, anytime. Watson needs you. This generation of problem solvers is going to learn much faster with Watson, and Watson in turn will learn much faster with us. Developers will solve new problems. Business leaders will ask bigger questions. And together, we'll do things generations before couldn't dream of. What will you do with Watson?
Yeah, good marketing, huh? So what will you do with Watson? So they've done quite a bit with Watson since then. Let me see if I can keep on playing here. So they're investing $1 billion into the ecosystem to help startups, figure out what they can do with Watson. They're pretty much throwing the kitchen sink on this sort of thing, right? So they know that their existing business is being disrupted, or the data centers and all that sort of thing. They're expanding into the cloud and cognitive computing. So they've single-handedly dubbed that term. And what this means for us is that, look, think about the doctors who, have to read lots and lots of books and on the latest journals, right? They think that Watson can ingest all that information and spit out the answers, at least to enhance those doctors who haven't been able to keep up with tens of thousands of readings every day. You can come up with all these nice apps that, customize to you. If you can, depends on what you like to do when you're traveling, they'll come up with a profile for you. And, Apple is having a big partnership with IBM to come up with those beautiful products. There's actually a Cognitoy thing coming out. So imagine a toy or Barbie that can speak to your child, right? And learn the personality of your child and get to know them and pretty much be that second parent while you're away. So kind of creepy, so lots of cybersecurity will also be important going down the track. ANZ's a big player in this. They're looking to do a lot of robo-advice, if you heard of that term. So getting rid of the middleman, essentially looking at your investment, risk appetite and coming up with everything that has been published for you. So that'll be entirely decoupled from requiring more investment in people and more into software and things like IBM Watson. So this bad boy here is called the Machine Intelligence Landscape. At Deloitte, I'm trying to come up with an AI report that tries to go through all of these startup companies that are disrupting what every other guys do, right? So if you think about over here, you got your professional and personal agents, so your Siris and your, you've got lots of like Cortana and Viv. So Viv is the team that created Siri, and they're going to create something that's like the Hollywood movie Her. You guys seen that Her movie? So it's about a guy that falls in love with his operating system.
Her.
Yeah, Her. Yeah. I know, right? Yeah. And people think that was science fiction, but it's happening today. If you look at the news today, there's an app called Rinko that the Japanese guys are falling in love with, and I think 33% would prefer the virtual girlfriend than the actual girlfriend. So that's the sort of society we're moving to, exactly, right? And they're going to the US and testing the appetite, and might not be as popular in the US, but eventually you can imagine that Rinko will have a physical body as well, and have all the haptics and all that sort of thing. So
that's super scary.
Exactly. So that's the personal side of things. The professional side, you got things like X.AI, which looks to organize your calendar invites. So remember I called about discussing about, okay, are you free next week? What time? Oh no, I can't do it now. That thing, if you see Amy, which is their product, Amy, she will organize and liaise with your other counterpart and help you put up those meetings for you. So a lot of pain points we have, personally and professionally, and these things are meant to come in and solve those problems for you. Looking at, the autonomous systems, we all heard about driverless cars. That's all relying on artificial intelligence. You've got, air, sea, ground, industrial. These are sort of automated systems that will, slowly take away what it means to have a job, going forward. So this is where we're coming in and trying to demystify all of this, bust a bunch of myths in our next report. We're looking to see, okay, what's hype and, what's under the radar, like all of these kind of things. and really just tell the story of what's happening now and what's realistically expected in the next 3 to 5 years. Yeah, there's a whole bunch. You know, we can go through it probably on a future day if you guys are keen to come along. We can talk more about that. So why is all this stuff happening?
Could you go back one?
Oh, one more. Yeah.
Sorry.
Effort. You can download this at, so a person by the name of Siobhan Zillas from Bloomberg Beta came up with this. If you can just Google Machine Intelligence 2.0, you can get the full version. So why is all this stuff happening? Why is suddenly in the news all this change? It seems it's a tsunami of exponential technologies and things that are having a huge impact happening today, almost every day. Well, Ray Kurzweil, who is the founder of Singularity University, along with Peter Diamandis, and also author of the book How to Create a Mind, has created this graph. It's called the Law of Accelerating Returns, which is a continuation of Moore's Law, if you say. And even before Moore's Law, it says that anything that has become an information technology grows with this curve, right? So if you think it doubles, you know, every X number of years, it could be 2 years or, you know, 18 months. It follows this trajectory. And this is a logarithmic graph, so it's actually, you know, much steeper. So, you know, it started with the, you know, the analytical engines, the Colossus, the Univac, the Apple II. And then all of these things happen, right? The PC, the Mac Pro, NVIDIA, you know, GPU, CPUs. And it thinks that eventually the computational power will surpass, you know, that of the brain power of a mouse, you know, by 2015, right? You know, we don't know what the actual brain power of a mouse is because you gotta, you know, properly measure it, but the measurement tools will also get better with time. So you can imagine at what point in time we can actually prove this sort of thing. He's been pretty accurate. He's been like 80-something% accurate in all his predictions. Yeah. So, you know, he thinks that this is, if you hear singularity, this is what he's talking about. By the year 2045, he thinks this, you know, the power of computing will surpass the brain power equivalent that of a human brain. All the human brains combined in the history of the planet. So he thinks something very special will happen. At that point, the curve will just grow exponentially. So, but as a science party, we've got to use empirical evidence and evidence-based policies. So until that happens, right, we've got to measure it against him. So maybe that percentage will come down a little bit, but it depends on how many years we're talking about. So, like we say in business, disruptive stress is also disruptive opportunity. So, you know, we could be here, right, when everything's sort of, you know, not really having much of an impact, and then suddenly you hit 1. So this is talking about exponentials. You know, if you think, you know, linearly 1, 2, 3, you know, your steps, take 30 steps down the room, you might end up on that side. But if you take 30 exponential steps, then, you know, you're at 1 billion. You're 25 times around the Earth, right? So that's the difference between linear and exponential. And another example of that is our famous business case of Kodak, where, you know, this guy came to the board meeting, you know, bringing out this digital camera back in 1975, right? It's like Steve Sasson came up with a digital camera, Kodak did. It was 0.01 megapixels and it weighed 3.6 kilograms, right? So, you know, Kodak's board was like, what is this piece of crap, right? You know, we're Kodak, we do beautiful photos, right? And then look at today, right? Well, yes, last year, you know, we got camera phones greater than 10 megapixels, you know, 1,000 times better resolution, 1,000 times lighter, and 1,000 times cheaper. Kodak's bankrupt, Instagram's out, and Facebook bought them out for $1 billion, right? So what's next? What is the human eye? The megapixel of the human eye is 576 megapixels. And just do the math, it's not that far away, right, if you're thinking exponentially. And the same sort of AI technology applied to the driverless cars. So before, you know, Google first came out with it, people were like, driverless cars, you know, what is that going to do? Is this going to, you know, no one's going to trust it, right, essentially. But, yeah, that's following the same curve. So phase 1, you know, from now until this year, right, this is last year's map, is passive autonomous driving. So you see in Tesla, you see that, you know, there's an autopilot mode, right? So cruise control, if you may, and you can lane change, you can auto park. Phase 2 is going into, you know, limited driver substitution, right? You fall asleep, it'll keep on going. Phase 3, complete autonomous capability, right? It can just do everything that a driver can do. But then at the end of the day, it's all about adoption. So they're thinking that, you know, in a couple of decades, it'll be 100% autonomous penetration of the market. You have a utopian society where no one gets killed by cars anymore. right? So, and that's all the players, right? There's plenty more to that, but Mobileye is one of those companies that is trying to retrofit your old cars that make it driverless. So, you know, maybe. What do you guys think? And the Apple car as well, it's coming out. So 3D printing is another exponential technology. You know, this goes back, you know, decades, right? It's really just additive manufacturing. You know, you're slowly one layer at a time, you're creating these things. But it's a $10 trillion industry. If you think about anything that requires a supply chain, this disrupts it completely. You can make things, your prototypes, you know, instantly, right? Not instantly right now, but, you know, in your sort of environment without waiting for an overseas manufacturer to come up with it. And that speed of 3D printing is also going to accelerate. Same with, you know, all sorts of the materials that you can use. What's really interesting is 3D printed organs. So if you think about, you know, the transplants that you have to be on a wait list for these days, if you can 3D print a liver, which Organovo is trying to do up here, and also 3D printed kidneys, yeah, it's going to be a lot of happy, healthy living lives going forward. Future of internet connectivity, we live in a world where 4 billion people are connected. No, 3 billion, only 3 billion. And Facebook and, you know, all these other players are trying to connect the rest of the world, right? So the population might grow to 8 billion on the planet by 2020. So think about what happens when you have another 5 billion connected users on the internet. Like all this progress that we've had in the past couple of decades, add another 5 billion to that, right? And yeah, so SpaceX is doing this as well. You know, the whole point is to, you know, make it cheaper to launch satellites into the air and actually create these micro satellites that can then beam down 5G internet connections to the third world and also to everyone around us. And Telstra and those sort of guys will just be that sort of distributor, right? So they're already testing it with Google Loon project. Have you guys heard of the Google Loon project? So Google's thinking of putting up these hot air balloons up in the air. They just tested it recently. It fell to the ground horrendously, but it was a controlled crash. They're going to try it again and again, and it's going to get to a point where you can have these permanently floating hot air balloons, or at least coverage-wise. You can just replace them for a certain area, and that'll beam down Wi-Fi for the world. And that's that right there. Yeah, exactly, right. Yeah, by that time, Ibm might show up in certain areas.
Down cancer.
Yeah, it's true. But by then we'll be able to cure cancer as well. So you'd be like, this is the future of healthcare, right? Great segue. I love it. It's part of the crowd. So we're all about health span here. You know, people want to live healthier and longer lives. And you got, you know, organizations like we talked about, Organovo, 23andMe, which has brought the price down of DNA testing to $99 US. SENS Research Foundation, which is specifically looking at how to cure aging, right? You got the Google Ventures headed up by Bill Maris, who is committed to living to 500 years of age, right? Like these guys, you know, they know what they're talking about, but they always sound crazy when it's like quoted like that, right? Human Longevity Inc., Peter D. Manders is the co-founder of that. So Singularity University, Peter D. Manders, Ray Kurzweil, they're all onto this thing. Right? And the billionaires are jumping on board. You got the Peter Thiels, the co-founder of PayPal, all behind it. Google's also invested heavily on Calico, you know, and DARPA is into this as well. Obviously, they want super soldiers that can, you know, outlast the enemy. You've also got Boston Dynamics. Who's seen the latest bipedal robot, right? Did you feel bad for that robot when you kicked it down? He was pretty drunk, right? But, you know, I mean, people are starting to empathize with these robots. Remember, like, you know, the dog that they kicked down? It's like, why would they do that? I think Peter's going to get on their case, right? So Google's also coming up with a smart contact lens. So this contact lens will be able to measure your glucose levels for diabetics. It'll also eventually become an augmented reality tool. So think about, you know, what Facebook and Microsoft are trying to do in the VR and AR field. This is the future of, you know, virtual augmented reality. And yeah, so you say, okay, look, there's going to be a whole bunch of people not dying on the planet. You know, what are we going to do with it? You know, they're all getting older and, you know, taking up the resources. Where are you going to go, right? Well, future of space exploration is all about launch, land, and repeat. Get them out of here on a Mars and multiplanetary and that sort of thing. But at the same time, remember that places like Japan, because of Rinko and that sort of thing, they're not actually growing their populations anyway, right? And you're looking at the Western world and sort of a consistent story. And aging population is a linear problem. There's the same people, they're getting older. It's the birth rates that's geometric. So you got an issue, but you can deal with it over time as well. You're looking at better ways to allocate resources, which we'll talk about a little bit later. You got better ways to be efficient in your food production and and all those sort of things. But yeah, space is the final frontier, as you may say. Let me just play a nice video that will demonstrate this vertical landing that SpaceX has been able to achieve.
There it is. Going in. Landing legs should be deploying in about 10 seconds or so. That is a view from the landing pad.
That is that first stage coming back down to land and picking up. History in the making, guys.
LZ1, the Falcon is landed. Landing operators moving to procedure 11.100. Section 3 on LZ1 VNet. Recovery net. Repeat, the Falcon and Falcon.
Yeah, I wish I was in that room right there. Right. It's nerding out, right? So yeah, there's a lot of hype about this, so take it with a grain of salt. This is the Gartner hype cycle. Some of you guys seen the Gartner hype cycle? Yeah. So, a lot of the stuff, gets hyped up really quickly. Blockchain's pretty big of the hype right now. AI, natural language processing, was probably at the peak of the hype last year. It's going to go through a lot of burning and crashing before people figure out what the real use cases are and what the real technologies are out there. So, like in the words of Warren Buffett, you don't know who's swimming naked until the tide goes out, right? So that's when the tide goes out and you get this plateau of productivity, and they think, enterprise 3D printing is there, gesture control is there, virtual reality is there. You can see Facebook at Mobile World Conference this year, right? It was like Neo from the Matrix walking down the path where everyone was wearing those Gear VRs. Autonomous vehicles. It is on that plateau of productivity. So, you look at Rio Tinto, they already got driverless trucks that are reducing the fatality rates on their mines and essentially, allowing them to open 3 months longer than than all the other competitors, right? So yeah, take it with a grain of salt, but that's pretty much the evolution of technologies, emerging technologies. So I help out with the Deloitte Center for the Edge. We delve into these sort of things, 3 to 5 year horizons and beyond. So, hey man, how are you, mate? And so Singularity University, we also have a partnership with them. We are hoping to host a Singularity University Summit in September. So if you guys are interested, I'll see if I can get some tickets. We also look at, this transhumanism stuff that I delve into as in Sydney, Watson's Apple Cars, Hyperloop. Everyone heard of Hyperloop? Yeah, we need a Hyperloop. Hyperbole loop. Yeah, exactly. So that's probably at the peak of the hype cycle. Now, Elon Musk really wants that for Mars, but he needs it for Sydney to Melbourne when he gets here. So, all right. Startup ecosystem. James was pretty familiar with this. These are all the sort of players, the entrepreneurs out there like Min and all this, and James and Meow and all these guys actually having, nothing holding them back apart from funding. So if we let their imaginations and their coding prowess advance, then we can help make the world a better place. And this is the Sydney futurist ecosystem, right? We got the effective altruists, the basic income lovers, and the Orbit Oz entrepreneurs, the transhumanists, the biofoundries, the science parties, the MCIC and augmented reality Sydney. There's a whole bunch there I couldn't fit on the slide, but we're hoping to put people all in the same place so that we can then, like I said last time, let their ideas have sex and create beautiful, beautiful children out there. Hope to see you at Future Day, the 1st of March. Guys, thanks, guys.
Thank you very much for that, Peter. That was really good. Yeah, and just another reminder about Future Day on the 1st of March. Come along. It's here, and it's going to be really good. We're going to have quite a few speakers here at that time as well. So next up is Meow, who's from BioFoundry.
I am indeed.
Yeah.
I'm just moving my speech across to here. So if anyone wants to grab a drink or go to the toilet, you got like 2.5 minutes.
It's a long walk.
Questions for Peter?
Oh yeah, sorry, yeah, Q&A.
Yeah.
All right.
Well, while we, toilet break Q&A. Toilet break Q&A. Sorry, where was SpaceX on the hype?
Ooh, I don't know. It probably was at the height, but then it probably went into the plateau instantly when it did the relaunch, when it did the relanding.
I couldn't see them. What is it? Space. Space something. They're not even on there.
No, it's what the billionaires. Yeah, that's right. What the billionaires do best is they combine a whole bunch of awesome technologies just when they're hitting the plateau into a beautiful product like the iPhone or anything like that. So what Elon has done is combine beautiful things for the Tesla, beautiful things for the rockets.
You've got my speech across there?
Yeah.
She'll be there now. I couldn't help myself. I want to just stick a couple more slides in. Yeah.
Is it up there on that?
Yeah.
Refresh.
Power of the cloud.
Power of the cloud.
I know. I'll just make sure it's all there. No peeking. No peeking. Okay. Could I just get a show of hands for who's seen me present before? Just out of curiosity. Okay, because I completely rewrote this, my normal speech, because I thought most of the people here I would have spoken to before. So that's the first time I'm giving this one, so we'll see how it goes. Quick introduction for those of you who don't know me. My name is Meow. I am a biohacker. I founded biohacking in Australia 5 years ago. It came out of a combination of things. I was about halfway through my degree and I realized that the graduate employment for molecular biologists after 1 year was only 52%. That scared the shit out of me because I was not the 48% that was going to get a job. So my average at uni is absolutely terrible. I have a 49 weighted average mark, but my third year average is a high distinction. And I wanted to basically I was looking for opportunities where people who are actively engaged and interested in science, but don't necessarily fit an academic model can still be successful, and that trying to find alternate pathways for those people. Me personally, I'm not interested in research. I'm interested in technology. I'm interested in taking the science that people do and then turning it into stuff that actually does something, because there's a lot of that doesn't happen. That's how you get a 49 average mark. So let's have a look. So this is basically just what we're going to go through today. I've changed it a little bit since then to make it a bit more interesting, and I've got some extra stuff at the end. So through discussion, we might actually touch on some of those slides. If anyone has any questions throughout this, if I use any terms you're not familiar with, or you have a question just in general, just stick up your hand and I'll grab it on the way through, and then we'll have some questions at the end. Okay, I'm a bit biased, so I think that I've cherry-picked a bit of data, but I've got this theory that biohacking isn't something new. It's like that we've been doing for a really long time. So some anthropologists think that brewing might have actually caused civilization. So it's pretty much undisputed that agriculture and civilization go hand in hand. Before that, we were hunter-gatherers. Why we had agriculture, though, is a bit of a different question. So some anthropologists think that we didn't start farming for food, but rather we started farming to produce alcohol. Now we've got, we have evidence of this. We have evidence of cultivated yeast that's 11,500 years old. So within a margin of error of 500 years or 1,000 years, we have evidence for that. But in Mexico, we have teosinte, which is this grain here. Now, in its undomesticated form, you can't eat it, but you can brew alcohol with it. So as far as I'm concerned, that's the smoking gun, and that was the birth of agriculture in Latin America. So straight on that one. So we interact with biotech all the time. Most common ways we interact is obviously everything over this picture, all the good stuff. unless you're on the paleo or Atkins diet. So beer, wine, bread, and cheese, that's how I'm most familiar. But what you might not be aware of is that, huge amounts of our cotton, sugars, medications are all produced using biotech. Things like human insulin and other types of drugs. So, basically to summarize, it's a more formalized approach to something that I believe we've always been doing. Yeah, basically that's a summary of that. Okay, so biohacking, what is it? So basically biohacking as it is now is, I'll just wait for this person to come jump in. Okay, so biohacking in its current form emerged at black hat hacking conferences. So it wasn't actually biologists that were leading this. So this is like the conferences in Vegas where people are looking at different ways of hacking different types of things. And some people who are now involved in DIY bio kind of started saying, can we do things like DNA extractions and do some molecular biology stuff at these conferences? And they did. And that led to one of them creating this thing called the DIY Bio Network, which is DIYbio.org. It's a way for all the biohackers to stay in contact with each other. After that, Ellen Jorgensen created GenSpace New York, which was the first ever space. They were doing things like public outreach using DNA barcoding. So if you brought in a sample of something from the park, it has to have been alive. It could be a piece of bark. It could be a leg of an insect. It could be a piece of meat. You could go in there and they would sequence it for you and just sequence one gene and tell you what species that sample came from. And any member of the public could do this. And they didn't do it on their own. They actually guided the citizen all the way through the steps, all the way through to interrogating databases to understand the entire process. So it's not just about, traditional citizen sciences. I go collect some data, I give it to the scientist does all the hard work, the scientist publishes. We'll touch on civic science in a couple of slides. Okay, so we also had BioCurious. Has anyone put up your hand if you've heard of BioCurious? No one at all. There we go, one. So it's probably the most famous probably the most famous biohacking space in the world. It does heaps of Kickstarters. They are the ones who are looking after the glowing plant Kickstarter. So this Kickstarter project was to make a bioluminescent plant. It raised $500,000 US and it caused a huge backlash from people who are against GMOs. So it's actually illegal now to give away a GMO as a reward on Kickstarter because of this. Anyway, the project's still going on. They couldn't stop it after it was already funded, but they could ban everyone after. So then we have, this is the timeline of DIY bio as in this incarnation. So then we had 2014, so BioFoundry and La Payas in France, which means the bench. We actually had someone present at Deloitte at one of our biohack meetings from La Payas, one of the founders. And 2015 was the formation of Indie Bio. And you can tell this is an old slide because Bioacquisitive was a question mark. They've formed and incorporated in Brunswick in Melbourne. We now have fledgling communities in Brisbane and Perth and maybe soon Adelaide. So Australia's a pretty exciting place for DIY bio at the moment. So just to give you a bit of an overview about what this is like a vision into my mind, tangled mess. So this is when I'm thinking about biohacking, these are the things I'm thinking about. So one of the driving forces behind it is hardware hacking. So it's probably the most accessible way to get into biohacking, which is looking at really expensive pieces of equipment, maybe, $25,000 or $100,000 piece of equipment and thinking, how can I build this for $20 or $100? And that's actually possible. We've done it. And lots of people around the world have. The reason is that the second you slap the word science on a piece of equipment, it all of a sudden gets a huge price tag, and that's not always warranted. We've got bioart, which I'll show you in a few slides. We have biotech and synthetic biology, which we'll talk a little bit about. But basically, synthetic biology is treating biology like an electronic system. So the way you might have a circuit, if I have a circuit diagram and I give it to you and you build the circuit, you would expect the same things, same behavior from that circuit as I would. Life doesn't always work that way, but a lot of scientists around the world are working out little systems in which that does always work.
Computers don't work that way anyway.
No, neither does electronics. Yeah, generally, you take this gene, you put it in that thing, and it should do the same thing, but then it doesn't do anything at all, and no one knows why.
What is the equivalent of a blue screen of death on a fire?
Hopefully, I don't even want to.
The Fly, the movie The Fly.
I think the actual blue screen of death would be when you put something inside a cell and it kills it.
Right.
And that actually happens
Actual death.
that's something that actually, actual death.
Actual death.
Surprisingly common occurrence when you're doing things like this. Actually, it'll probably be contamination. That's what I do. Whenever I'm working with things, something else from outside coming in and killing the thing you're working with and taking over it. So then we've got civic science, which I touched on a little bit, which is citizens getting involved in all aspects of the scientific process. We've got grinding. Anyone heard of grinding? Do we have any grinders here tonight? We have before. So there's people that want to put.
Is that like Tinder?
There is one like that. I think I might have seen you on that. So grinding is taking technology and putting it inside your body or modifying yourself. So the examples you might have seen is microchipping your hand, magnets in your fingertips, sticking computers inside you sometimes. So yeah, whole like huge bits underneath the skin and all that stuff. And we've also got a really awesome neurohacking and transcranial direct current stimulation group. So this is external, but it's looking at ways to modify your brain through electricity. You have things like brain-computer interfacing and things. I would classify all these things as biohacking. The ones I've got with a star are the really big commercial ones that I think the government should focus on. So I'll just give you a quick rundown. So I started BioFoundry out of Biohack Sydney. It was a meeting group, much like we've got tonight. After 3.5, 4 years, we got an exec team together and decided we were going to start a lab. I dropped out of university and worked on it full time. And from that partnership between myself, Maria, and Adrian, and also with the support of all the other biohackers, we have managed to keep our lab alive for over a year, and we're now breaking even, which is incredible. Hey, actually, for a not-for-profit charity is fucking huge effort to get there. So really, really big. But as you'll hear later on, there's been some great successes come out. So this is what we started with. Does anyone want to give me an impression of what they think when they see this?
Meth lab.
Meth lab.
Fancy meth lab.
Clean meth lab.
Yeah, so there's all sorts of stuff going on. This is like the workhorse. This is the type of machine that was involved in the preparation work for sequencing the human genome. So this thing's quite old now. In the grand scheme of molecular biology, with fluorescent microscopes. I actually used to show this to people to tell them how impressed with the lab I was, but I'll show you BioFoundry in a second. We've come quite a long way in a year. So you don't need a whole heap. You can scavenge everything out of a bin. You can bootstrap a biohack lab. You don't have to have $100,000. You don't have to have $250,000. You can build this for $5,000 or $10,000 or less. This is one of my favorite photos of an event we had at the old BioFoundry. So this really shows what I think of when I think of biohacking. This is community coming together, peer-to-peer education. We have a writer and an artist, a world-famous molecular biologist. We have a hardware hacker. We have all these different people collected in a space, teaching each other and learning about science in a fun way that's not like force-fed theory and a tiny little bit of practice. They're actually building and were successful in making a microscope out of a drop of water. And they shine a laser through it and that projects it on a wall. They got it working for about 3 seconds. That was the most amazing 3 seconds. Being able to see bacteria projected on the side of this warehouse. So that was very cool. And now I'll see if this works. Everyone cross your fingers. Oh no, it looks like it's gonna work. Okay, so this is BioFoundry now.
In the same location?
No, we're in a different location. So we've come quite a long way. We got a lot more equipment. It's a much more professional looking lab. Just to give you a quick rundown, most of this equipment was given to us by universities, and there's no secondhand lab market in Australia. I'm not going to go into the details, but basically there can't be one at the moment. So because of that, universities give us equipment for free. So we're very, very lucky. The ticket price of the equipment in most of that, and the big ticket items we have in that lab, when they were bought a few years ago, is over $1 million. And because of the acceleration of molecular biology that's being driven by the technology, we were able to get that for free. They replaced that with one machine that's now worth $1 million. And they bought that 8 years ago. So, and that was hugely dated, but we can still use that to do really powerful stuff. We have time to sit down and program things they don't. Okay, so this is our lab. There's a bio art course that we're running. These are the types of events we like to run. We have all these people working together, doing cool things. I'm just going to quickly touch on this. The biggest concern that's always raised is biohacking safe? You know, we're not playing around with Lego or anything like that. We're playing around with biology. Huge problems that affect mankind is and always has been are biological in nature. We have viruses, pandemics. We're reliant upon biology for our food supply, some of our fuel. Basically, in short, UN did an investigation into the biohack phenomenon, and most major governments around the world have. And their take-home message was that not only are they safe, they prevent bioterrorism. Does anyone want to hazard a guess as to why that might be?
Educating citizens, making them more literate about odd things going on.
Most definitely. Any other suggestions? Who might perpetrate a bioterrorism attack? So the big terrorists that people are worried about are generally lone wolves. So you get collectives of terrorist organizations, but in general, they're not the main threat. The hardest people to find are lone wolves, people that act independently from the state or any other group. By providing people a place where they can do biology, and in particular molecular biology, you create and making it welcoming and a peer learning environment, you actually remove the peer wolf the lone wolf motivation through creating somewhere where they feel comfortable. So it de-radicalizes people to have community science spaces, if that makes sense. That was the finding of the UN. So that's pretty cool. So we should have these spaces around. They're really important. And you're right. If something goes wrong, we'll know how to identify it. If everything goes down, we'll know how to fight it because we have the tools to be able to produce the solutions to the problem in the first place. If anyone wants links to that as well, I can send it through at the end. Okay, so how's biohacking different to traditional biotech? And I think the biggest thing is that traditional biotech is implicitly profit-driven, where they've got these huge big companies that want to give value back to their shareholders, whereas biohacking is community-driven. I'm not going to harp on about this. I think both of these are very important. You can't have an ecosystem without you can't have an ecosystem without traditional biotech. You can without biohacking, but it's important because the product they produce isn't always the product you want. So I've got here that the end goal is to return a return on investment. The consumer is not always the person buying the end product. So we all eat fruit and veggies. What do you guys want from your fruit and veggies? Nutrition? Flavor? I don't hear anyone calling out shelf life or resistance to pesticides, but that's ultimately what the person who's manufacturing the crop wants to sell, because the person buying it's the farmer, not the end user.
But we want cheap vegetables, which means all those things.
Definitely. Would you pay more for something that was more nutritious though?
No.
Or more flavoursome?
I'm cheap.
and you don't have to buy it either?
I expect it to be more for the cheaper price. I think
yes. Which is possible as well, especially when you have lower overheads than traditional biotech. You can actually put this power into the hands of the citizen. So you could grow it, which is free, and you can create those seeds in the lab and take them home. So ideally, that would be the end goal. It's also important because the decisions that the biohackers make are community focused. So we might be focused on biodiversity. There might be concerned members of the community that want to ensure food security and biodiversity. That's not necessarily, it can be, but it isn't always the direction that goes, because often it's not people making decisions, it's shareholders and things guiding things in different directions. So that's why I think there's this real need for biohack labs. Anything else?
Where do you put government research?
That's a very interesting thing. So I've actually got a slide on this a little bit. I think that it depends on the government and what they want out. If I would personally love to see biohack spaces like libraries. We are actually seeing this. If anyone's visited the State Library in Queensland, they've got a building called The Edge, which is a hackerspace, makerspace with a bio component to it. The government already supports men's sheds, and these are places that are actually mental health as well, mental health support centres, as well as places that people can build things. So heavily community focused. I would love to see biohack spaces sponsored by the government. I would love to see these spaces rolled out in vans to rural communities and make biotechnology an important part of the national discussion. I think as well, like I personally believe that getting involved in politics, art, and science are all civic responsibilities of every single person. I'm going to actually, that will lead into some discussion a bit later on. And probably the biggest thing is biohackers generally have open IP and traditional biotech generally has closed IP. And that's one of the biggest reasons that we need both of these. Because I think having both these things in different situations is actually quite good. At least while we're in.
I actually think the left side will overpass, will take over the right, but
in capitalism, I think so as well. But I think where we are now with our patent system and the way that capitalism is, this works well. But we can't have just closed IP. We can have just open IP, but we can't have just closed IP. And we're somewhere between these two at the moment. And there's definitely a tendence towards the other one. Okay, public opinion. Yep.
When you're trying to get good nutritious food, right? You're negating that nature can do things in a productive way, as opposed to just thinking we have a solution to make it better.
Yeah, but all the food we have today is we made.
Yeah, but that's today, and that's under the parameters of profit.
No, corn today is we grew it to be corn today. Corn before is not edible. So humans already made that. It's not biohacking.
Okay. Anyway, just saying there are things that permaculture can do.
Yeah.
To leverage that we can keep our hands off it.
Yeah.
That's all. I'm just saying.
Oh, that's okay. It actually ties into this next slide that I'm interested in. So I see genetic modification, especially when we're talking about crops. A lot of the times this conversation comes up, we're talking about crops and food security and things like this. Who's in charge of this? Which direction is it going? That's probably. And biohacking probably came out as a response to this community fear, and this community fear is actually quantified right here. Now, what you were saying before about crops being important and not just being food producing and all these things, I heavily believe in permaculture. I run permaculture courses and I'm involved in the permaculture movement. There's some things I like, there's some things I don't like about it, but I think it's a very sensible approach. I don't think it's sensible on a commercial scale as it is now. I think it could be with enough government support. But I think the beautiful thing about permaculture is it says agricultural crops don't exist in isolation. They exist in an ecosystem, and you really need to be aware of that, especially in a country like Australia where we have high fire danger, and you can put biological controls to limit the impact natural disasters can have on our food production. Okay, so the big thing here I want you to have a look at is that top one. So what it's saying is only 37% of American adults think it's okay to eat a genetically modified crop. 88% of scientists think that it's okay to eat a genetically modified crop. So there's no bigger disagreement between public opinion and scientific opinion. And my question is to you guys is like, how did this happen? So the difference in that is bigger than the difference between scientists and the public on climate change, on vaccinations, on fracking, on space exploration. This is absolutely massive. How did we get to here? And who do we blame and how do we fix it? And that's one of the big questions I ask. And that's a big driver for me to run Biohack Labs.
Can I give you a solution to fix it?
I'm all ears. Let's do it.
You've got to change the parameters for how GMOs are created.
Okay.
While GMOs are commercially driven,
then
you're always going to have an animosity against it.
Yeah, I agree.
The two, I mean, the two together is GMOs create the disease, and they got the drug companies making themselves to resolve it.
That's exactly right.
Okay, so while you have that market, the parameters that feed that market, you're going to have that diametrically opposed.
Exactly
thing,
right.
Okay, so if you change the parameter, change like this is totally quality driven. We know that it's safe. That it is not commercially driven. It's the only way I know how to do it.
But
it's community driven.
The reason why the scientists think this is because in fact that is how it is done. That's what actually happens. Bill Nye changed his opinion on this purely because he came to understand that the big companies that we all don't like actually do qualitative studies and test everything. That's why scientists are at 88% of people.
Then why do all the reports and so on and so forth that people read and go like, why haven't they made this public and so on and so forth? You know?
So I think the big thing is that it doesn't make for good news to say a big company does a nice thing. Really, like if I came out and published, oh look, Monsanto is doing great work in feeding the third world for free, with GMO crops that address their nutrient deficiencies, which actually happens for free. No one's going to read that.
Things like Terminator seeds, you know what
Yeah.
I mean? Like if they were, if
Most
you're going to
definitely.
make something that's good,
Yeah,
you don't build Terminator seeds.
that's a complicated
Do you know
issue.
what I mean?
So the Terminator technology has never actually been put into any plant. We have the technology. If we wanted to do it, it might work. Never been commercially released.
Really?
Now, 100%. I'm like, I've read every single thing you can ever imagine about Monsanto. Seriously, I'm an expert. If you want to quiz me, I'll debate anyone non-stop.
That the way to bring the population to the 88% is by educating.
100%.
That's the difference between a scientist and a...
I agree.
So
I'd just like to suggest that I think a big part of the problem here is also between the scientific rationalist reductionist approach and versus increased knowledge about complex systems and social and biological systems.
Yeah.
Now, there is clear examples, say, for the commercialization of something, that it will run towards a kind of reductionist approach.
Yeah.
The focus is on a specific measure, usually money.
Yeah.
And sometimes that means, and that's a common approach of science, which I'm not disputing its importance. The trouble is that when you, and this is where biotech causes a lot of fear amongst people in the public, is that you have someone saying, oh, we know exactly how it works. And someone looking at the biological system and saying, nobody knows how it works.
Exactly right.
These claims are clashing.
Yeah. So I think
you need to talk, you need to address that.
A huge part of this is scientists not doing their job and communicating to the public effectively. A huge part of this is Monsanto not managing their PR effectively.
Well, it's not what they, sometimes they're just not doing it.
Exactly right. And we're at a stage now where this exists. So with, in my opinion, I think that one of the best things we can do is change education on a federal level to encourage more understanding from a really young age. And also through community engagement, through practical education in places like Biofoundry, where we can invite people in to make a GMO and make sure that if we are worried about GMO crops, that we're having the right conversations. The conversations isn't about whether we should use GMO or not. We genetically modify things all the time. It's another technology we use, much like selective breeding or anything like that. It's about what genes are we putting in and why are we putting them in and how often are we doing this and what's the end goal. Those are the conversations.
The parameters.
Exactly right. And those are the conversations the public should be having. So, how am I going for time, by the way?
We're at 7:30, so.
Okay, I'll zip through this real quick now. Is everyone ready? Take a deep breath. Straight to the end. Okay, I'll just zip through. Okay, so this is a graph. This is the famous graph you see in every bloody biotech presentation. This is the cost of a sequencing a genome over time, basically. Megabase per sequencing over time. This white line is Moore's law. This is 5 times exponential decline in price. I just want to highlight 2 sections. That one is when next generation sequencing came in. This is a huge change in the way that we think about how we sequence genomes. Basically, it uses the power of microfluidics and computer processing and doesn't focus so heavily on the biology, and instead thinks, how can we massively parallelize and split up the processes and use the power of supercomputers to assemble genomes faster. The next big one happened just last year, and this is our movement onto solid state sequencing. So it's, instead of being microfluidic, it's now nanofluidic, and we're looking at things like fusing machines and proteins together. So you have these combination systems where you have a protein on a silicon microprocessor, and as the DNA zips through, it causes current changes in the silicon itself.
That's cool.
Mental. So cool. This is like desktop sequencing. This is when it gets really fun. This is when you can take it home and find out who your daughter's been. See?
Maybe she's not your daughter.
There's actually a lot of ethical issues in in universities about doing anything like this. So, just a funny aside, we used to do this test where you would check to see whether you're male or female on your DNA, just as like a stock standard first year prac. But we can't do it anymore because people have Klinefelter syndrome and all these other major chromosomal abnormalities they weren't aware of. The school's liable and they have obligation and duty of care to give them follow-up counselling and stuff. So now we see whether the animal sample is male or female. Okay, so this is kind of the state of the world as America sees biohacking at the moment. So just give you a quick, super quick rundown. So this is Australia. This is what Indie Bio in San Francisco thinks is happening in the world of biotech or independent biology. So there's Australia here, BioFounders here. That's what's going on in California. That's what's going on in America. And surprisingly, this green stuff is what's going on in Europe, and the purple stuff is what's going on in Latin America, so Mexico and South America. Now what's missing from this? Asia and Africa. There is stuff happening in Asia. We don't often hear about it because there is a significant language barrier. It's not great internet all the time. It's hard for them to get in contact. They kind of work in isolation. And as far as I know, there's nothing happening in Africa. Okay, why do you need biohack labs? Sacha Karberg found that some dog was pooing on his front lawn every single day. So he went into GenSpace with a sample of dog poo and said, how can I find out whose dog has been pooing on my lawn? So he came up with this idea that if he gets tennis balls and throws them to dogs in the park, then takes their saliva and then sequences it. And eventually he caught the dog. He caught the dog that was pooing on his front lawn. So this is how a biohack lab might affect your day-to-day life. Okay, so I think it's this one. Incredible. So there was a cool artist, Heather Drew Hagberg, who was like, what do we throw away when we think we're leaving nothing behind? So she started collecting litter on the New York City subway and then doing 23andMe genotyping on it and then using that to predict what the faces would look like. I thought this was bullshit. And then when I looked at the science, I realized it was probably scarily accurate. When she did, she started printing out these faces and put it above the litter. So this is 2013, May. 2 years later, Hong Kong released this. And then I think I'll finish up after this. Let's have a look. One, maybe. Are we going to do it? Maybe not. Basically, here we go. There we go. Play now. No.
Just reload it.
Playing. Actually, I can, hold on. I can reload the entire thing. So 2 years later to the day, Hong Kong released a campaign that littering is not an anonymous crime. And they were putting people's faces up on billboards using exactly the same technology. So this went from being an art project criticizing where we might be going into government practice, where they put your face up on a giant billboard with your cigarette butt or your piece of litter underneath it. So
was the original artist involved at all?
No.
They just went,
yeah,
we'll take that.
We took it. They took it. Okay.
When you have open IP.
Yeah.
Science imitating art.
I'll just quickly touch on commercialization. So where is kind of biohacking going? It's it's cool. We do the community. There's always need for it, but it's also incredibly valuable. In America, global class startups last year raised $506 million, and these are like the big startups. This isn't even indie stuff. This is kind of somewhere university spin out level. Half of that was from CRISPR-Cas9. We've got that technology is only a couple of years old, and the companies are increasing at a huge rate. So in 2012, we had 6 global class biotech startups coming out of America. Last year, we had 24. If you think about where this might be going in the next few years, it's pretty exciting, and it's important that Australia jumps on this. At the moment, we are sending biotech companies across to Indie Bio in San Francisco. I'm going on Tuesday. Woohoo! Fuck yeah. Why do I have to leave Australia? Why can't I do this here? So I'm getting $250,000 American to start a biotech company working on a project that will make a lot of money, but is really boring. So a project I worked on in my honors is also over there. So they are doing things like vegan egg whites. They are making wound healing fabrics from biological sources. They're making 3D printed rhino horn. They're doing biotech gelatin. They're working on meats. They're working on sticking this blew me away. Koniko, this African dude came up with this idea for a way to do computing using neurons. He stuck them inside a drone, and this drone can smell things and fly towards it. So the fusion of biology and technology on another level, which is really cool. And they're chucking, so they're funding 30 companies a year for $250,000. So they're chucking, say, was it $8 million a year? Out of $9.7 billion in the Liberal government's innovation portfolio, they gave $8 million to accelerators. All accelerators in Australia.
Actually, I didn't give it to them. It was a tax incentive.
Oh, was it? Yeah.
It wasn't even money.
That basically they are investing as much into groups like myself as one venture capital group in America is doing. And the rest of that is money for investors and tax breaks and all this sorts of stuff. We do some good things like R&D tax incentive, I'm not gonna lie, but like they're trying to cut that too. How do we fix it? Give money to the inventors and not the investors. Really support them, support low-level startups which have high chance of failure but cool ideas that you get a lot of bang for your buck. I'm going to put these slides up online. I'm going to send them through. So if anyone wants to have a look at the rest of the stuff that I missed out on, there's a whole heap of projects at the end that are really funky and you should check them out. And I'll close it up there. Thank you very much.
All right. While I'm getting ready, we might have some questions from Meow.
Yeah, cool. Come on, biohacker.
You had a lot of startups in the last one. Big corporations doing this sort of stuff.
Okay, so biohacking really exploits a big part that's missing. So generally, the big corporations are looking for big returns. So what they're looking at is like, what's that?
Too much risk in these startups.
Yeah. Okay, so you're looking at like generally drugs. You want anti-cancer drugs and things like this, right?
Yeah.
So you have a huge lead up, you have a huge ramp before you get money. But when you get it back, you're getting, for a very small investment in the beginning, which is way bigger than what these groups are getting, you get, billions of dollars, tens of billions of dollars, hundreds of billions of dollars, potentially even, in things like antibody therapies for cancer. When you're looking at 3D printed rhino horn, it might not have a huge return, but it's that typical startup thing of finding a niche, exploiting it, high margin, small market, and then cracking that wedge in and opening it up. And biotech is finally on board with this lean startup model. Yeah. Question.
Oh yeah. If I breathe every 1 month for a dog,
Yeah.
can I come to your lab?
You actually can.
Yeah.
So we've got a microarrayer that does the 23andMe testing. It would take you a while to do it, but yeah, definitely in conjunction with University of New South Wales, you could do it because they have huge libraries of DNA that's not being used that's looking at dog breeding. So they work out things like how much % dingo is my dog, which is the driving force behind it. But they also work in what different conditions your dog might have, and basically 23andMe for dogs, which is cool and useful. Yeah. One last question.
Are there other science hacking places around? I think I've asked you this before, but
in Australia or around the world?
Australia.
Not that I'm aware of. Okay, so we've got Bioquisitive in Melbourne, we've got BioFoundry in Sydney. We should have Substation 5 in Queensland by July. We should have another space over in Perth. There are some university level places, but not accessible to the public. There are kind of little interesting pockets all over the place. So sometimes a council might have a room or something that might do one particular function, but not like Oberon Visitor Center, for example, teaches you a lot about mushrooms and then encourages you to go out and interact with them. I would say this is a similar kind of thing. But as far as it goes, not that I'm aware of, or I haven't been in contact with them, which is sad. There are a lot of hacker and maker spaces though, and that's a way that you can get engaged with that.
So there are a few places around Australia, Melbourne, and you're setting up Brisbane, right?
Science hacking.
Oh, it's separate to BioFoundry.
Yeah, there's Melbourne at the moment.
Yeah.
Hopefully we're going to have Synth Space, which Tom's getting involved with, which is a chemistry hacking space. And maybe if someone in the audience would like to start a physics hacking space, we'd really like that too.
Yeah,
I know.
Yeah, you know a guy? Yeah. Don't worry, particle accelerator. Awesome. Thank you very much for being great, guys.
Thank you very much to Peter and Meow for those presentations. They were really great. We love that sort of stuff, the acceleration of technology, the exponential growth that gives us high quality of life, and also putting it back into people's hands. This is fantastic that people can start to do this stuff on their own, take technology that already exists and do stuff that solves their everyday problems. So I think this is really exciting stuff that's happening. Tonight's host, this is the Science Party meeting, and I thought I'd give a bit of an introduction for people who aren't members yet. So we're called the Science Party, but we used to be called the Future Party. We've been registered since 2013. We've run in 3 elections, the 2013 election, the New South Wales election, and the North Sydney by-election. So we've been around for a while. In that time, we've learned lots of things about how to organise better and what people like. One of the things that came out of the North Sydney by-election was that our name needed to mean something more. And we did some research into what would be the best name, and we ended up going with the Science Party. So what do we stand for? This is what we've been running under for about 3 years: innovation, education, and economic reform. Now, these things are not changing about the Science Party just because we're changing the name. These things are extremely important. Creating new technology, educating people, and improving people's quality of life through economic reform. So there are some meaning changes that come with the word science as opposed to future. So, sorry, I got my slides wrong. So this is what we thought that we should have a general meaning to the party. We should have a principle statement which outlines our core beliefs so that people know exactly what we're standing for. So we have science and technology. We believe strongly in investing in that. Investing in education, protecting the environment, economic development and progress, public health care, evidence-based policies, that's a really important one. Open and efficient government, because you can't do science without data, and you can't hold a government to account without knowing what they're doing. A compassionate safety net, because that's what scientists do. We're making the world better through science, and we need to make sure that people don't fall through the cracks as well. We believe strongly in migration, because a human is a human. We believe strongly in individual freedoms, ending discrimination, and a secular government that's not beholden to any particular religious belief. So what does the Science Party do in particular? So borrowing from the idea of what a scientist is, a scientist looks at evidence and then they make additional observations. They perform experiments. So you could imagine a science party doing some risky things, some things that might fail, and some things that might succeed fantastically. So we make decisions using mathematics, reason, and logic. There's a formal process to this stuff. We spread knowledge for the benefit of humanity. So that's the education side of things. And we change our opinion when new information comes along. We're not ideologues. We're only ideologues to the idea that, we want to learn more and we want to make the world a better place. So what can you do? So these are some of the pretty simple things. You can join our social media groups. So the Science Party Facebook group, you should jump on it and you should invite your friends and share and like posts by the Science Party. In doing so, you actually do free promo for the Science Party. We had someone add, I think it might have been you, Peter, add about 300 of his friends to the Science Party. By inviting all those people to the Science Party, by inviting all those people to the Science Party,
you have
that's
300 friends?
yes, quite a few thousand more of them. By inviting all those people to the Science Party Facebook page, he gave the Science Party the equivalent of around about $300, right? And that's just scrolling through Facebook and clicking invite, right? You don't have to do anything. You could do it on the bus, right? So get onto Facebook, like the Science Party Facebook, and share it with your friends. We also have some other Science Party Facebook pages. So the Human Advancement feed, the idea behind that is we throw in brand new developments in technology and science. And the idea is that it gives you a high frequency update of really cool stuff that's happening in science and technology. More fun than serious stuff. We also have the Science Party discussion group. That's really great for you to get on and have discussions about policy, current events. It's a much better forum for discussion than the Science Party itself. Science Party Facebook pages like push out and share and spread the network, whereas Science Party discussion group is more about, joining us and hearing your opinion about things. And also there's the Science Party Australia Twitter. You can like and retweet that. Like, follow, that's what it is. In addition to that, we really want more members. Becoming a member is really important. You show support for the party. There is a fee involved. So if you're earning below $50,000, it's $52 per year, or the equivalent of $1 per week. If you earn over $50,000, then it's $104 a year, or the equivalent of $2 per week. So it's really not a lot, especially in an election year. If you can't afford it though, there are methods you can ask for a fee waiver, and we can give it to you, if you're going through a bit of a tough time. Just to give you an idea of why we need this membership fee, running every Senate spot in Australia will cost us $80,000. That's not including the lower house spots. So it's an enormous expense. If we were to do New South Wales alone for 6 Senate seats, which is pretty much the only way we'd show that we're serious, $12,000. We hope to run in New South Wales and Victoria at the Senate level. We're looking at Melbourne in Victoria for the lower house, and possibly a few places like North Sydney, Grayndler, Sydney, Barton, and a few other places in Sydney as well. So there's a lot of cost behind this, so we need as much support as possible. You can also volunteer. We need people to work social media to make sure that it's up to date and people are responding in time. We need people to work media, so doing media releases, being contacts for various journalists. That's a very important job, and currently it's really only done by myself, and there's only so many things I can do at one time. We have a fair bit of design to do, and most of it is incidental stuff. So when we put up a Facebook post, it gets a lot more likes and shares and goes out to the community more if you create a custom image that represents that information. So we need people to help do these incidental things. We're also talking about doing some VR space and doing some VR promo for the Science Party. So if you're into VR, put your hand up. There's actually a Facebook group called the Science Party Design Buffs, where we discuss that sort of stuff. So get involved in that as well. And we need people to process memberships. This is a huge process. We have 950 members, and we need to make sure that they're looked after properly. When they come in, we need to make sure that they're processed. We need to make sure that they know what's going on in the party and feel welcome. So you can additionally donate. So we're going to have James, who's going to be looking after receipts for donations. So if you're thinking of dropping some money in, we're also going to have a computer over here that Jake's going to look after. And Jake's up the back there in the yellow shirt, if you want to join as a member. So you can do that after this talk and some discussion afterwards. Join our twice weekly meetings. We meet Monday and Tuesday nights at 6:30 online using Mumble. Quite a few of us do it. It's a highly productive meeting. It's not like a lecture at all. It's like going back and forth and doing little tasks. There's heaps of work to do. It's just a matter of how many people get on and do it. So like if you're thinking of helping out, jump on Mumble.
Yeah, Mumble's really cool. I couldn't figure it out on the PC, but you can install it on your iPhone or Android.
Yeah,
it's pretty good.
It works pretty nicely.
Yeah.
Very, very clear. I'm just going to go through a few things that are upcoming. So federal election. It's pretty much almost certainly going to be this year. It could go out to January. It could be as soon as like a month and a half from now if they do a double dissolution. I don't think that's very likely, but this is the big thing. The federal election is coming up and we need people to get on, support the Science Party so that we can have a huge impact. Now, there's a huge thing that's changed just recently, and that's the group voting ticket is looking likely to be abolished. If you don't know what that is, the group voting ticket is where you vote one above the line and then the party distributes the votes below the line. Now, there's been accusations that it's being gamed and that, you know, there's preference whisperers and it gets right-wingers involved. Obviously, we're not on that side of politics, but the removal of the group voting ticket is going to result in a lot of small party preferences expiring very, very early. And what that means is that unless you're getting extremely close to a quota, you won't get elected. And the ultimate result of this is the biggest parties are most likely to get more up. And that could result in a Liberal Party dominated Senate. And that would be a disaster. This is a real possibility. If it went to a double dissolution based on voting numbers in the last election, we'd have complete control of the Senate by the coalition. So what would that mean? No checks and balances in the Senate. Work Choices 2.0, that's what they tried to put in when they had complete control of the Senate. It completely restricted workers, and you can have your opinion over how flexible working arrangements should be. But if you think they should be flexible, then the workers should be able to walk out and say, I no longer want this job, and not get a fine for it. That was a really scary situation that we had with Work Choices, and the Liberal Party could get away with anything. So how would that affect some of the stuff that we're interested in very specifically? So they've tried to bring in a lot of education cuts, and you can guarantee that they'll go through in their entirety if the Liberal Party controls the Senate. Science cuts. We had the science minister completely disappear. Now they're part of innovation and industry and science, and that minister has no time to deal with science at all. Still no real science minister. CSIRO has had a huge amount of cuts. We've had like climate scientists disappear really quickly. It's really quite scary, you know, and this is a systemic thing. For everyone who says, oh no, it was just Tony Abbott. At the New South Wales level, our very favourite Premier Mike Baird is a Liberal, he's relatively progressive, and yet he's still cutting New South Wales water scientists who look after our water security. You can guarantee that this will continue if the coalition get in power. We really need to get on this election. We need to make a huge impact with as many, in coalition with as many minor parties as we can. I'm running a group of minor parties called the Alliance for Progress, and we meet up and share ideas and run campaigns together. So this could become the next movement if things go too far with respect to the GVT, but we really need to get on towards winning seats in the election so the coalition don't control the Senate. So upcoming in terms of, what we need to get there, we're going through a bit of a process now of making questionnaires for candidates so that we can do nomination processes. We need to get funding campaigns for the candidates. So we're going to run independent funding campaigns for individual candidates so that we can get as much money in as possible to get people nominated and onto tickets. Okay. We also need to, so we're in the process of rebranding at the moment. So we have new candidate logos coming through. We need to do a whole heap of design throughout the website, Facebook, Twitter, all sorts of design aspects. So that's a huge thing at the moment. Making sure our message is right on point is part of that rebranding campaign. And membership renewals. So the majority of membership renewals have not come up since we instituted the membership fee. And so we need to make sure that as many of those people who are currently members under a free membership translate into a paid membership, or at least acknowledge that they would like a free membership and get them into the system. So we're going to need a lot of help doing that, contacting people individually to keep them in the system. So please get involved, join the Science Party, join our social media and put your hands up to volunteer. We'll be standing over here in a minute to do that. So I think, have I lost control? I think that's the end. Yes, excellent. Okay, thank you for your attention. Do people have questions about that?
I should just have one statement. When we see things like water scientists losing their jobs, at first I asked some of my lecturers, like, oh, what's the problem? Can't we just hire more? When they closed New South Wales fisheries down at Cronulla, you fired a group of scientists that had on average 20 to 30 years experience. When you fire them from those positions, you have two options, which is to contract them back or replace them with new scientists. You can't just replace some of these jobs that are going. There is no option to. If they decide to leave the country as a result of being fired from their job, you no longer have that intellectual property inside the country. It's gone forever. And the more successive governments that you have getting rid of things like this, you erode all scientific capital that you had to begin with, and you can't replace it. You have to wait 30 years for it to come back. That's why it's important that these things happen like this election, or actually 4 elections ago. So that was just my 2 cents to add in.
Yep. Do people have questions about the membership?
You mentioned rebranding. You've got the Science Party logo up there.
That's not the real.
Okay, so that's the interim logo.
That's it's supposed to be. It's literally, when I made this, it was supposed to be like insert logo here as much as possible. Turns out people like it for some reason. So yeah, this is our interim logo. We have 2 candidate logos which have gone out to a bit of a survey, and we're collecting up the results right now. It's looking pretty close between them. They're both very nice logos and have various good and bad aspects about both of them. So yeah.
Do they both have hexagons?
What? No.
One in the sample.
Not exactly. Neither of them explicitly have hexagons, but the inspiration for one was from hexagons.
Okay.
So yes,
A/B test right now.
we're doing.
No, like in this room.
Where do we have them, Andrea?
It's in the executive survey.
It's in the survey. Oh yeah. I don't have it here on my thing.
I tweeted them before, James. Is that all right?
Did you? All right. Cool. Yeah. So, is there anything people want to discuss about, like what could happen in the upcoming election? People might. Yep.
Oh, just not on that subject, but just as a Science Party curious. I obviously would like to learn more about your strategies and plans for policy making, things like that.
Yeah.
So what open source is there that I can get onto that for?
So if you jump onto scienceparty.org.au, this is our website. Internet's great here. So our federal policy is here.
Excuse me.
And so we actually have a 19 section But yeah, so federal policy, it's in here. You can go into each of the details. Here we regularly discuss new policy items on the Science Party discussion group. So get on there and make sure you join that group, and contribute to that. We really like people to help out with that. Yep.
Typically, if you have some kind of data or evidence that might suggest one of the policies is not ideal,
Yeah. So yeah, if there's good evidence that our policies are really bad, then we. Yeah, exactly. so yeah, we really think it's important
what sort of political party is this? I've never heard of such
no, not about like
transparency.
Yeah, complete transparency, radical transparency. Yeah. All right. Yeah. We've got a bit of time now. Do we actually have spare?
Hey?
Do you have drinks?
Oh, we could go to the bottle shop down the road and pick us some up.
Yeah.
Put it here.
What's the time? We're still allowed to have a drink?
Yeah.
Well, it's 8:04. Yeah.
The sun's coming down.
Yeah. So it's still open. Mike Baird hasn't called bedtime yet. So yeah. Oh yeah. So if you are heading off right now, right at the top there, join, volunteer, donate. Get into it. We really need all the support we can get, and you'll actually be helping pushing the party forward a lot. And tell your friends. And we'll have people set up here to take your details as well if you want to do it here right now. Cool. All right. So let's socialize with you.
Yeah.
Part of the EA thing.
Yeah.
Oh yeah, it's good.
Really good.
The lights on that side?
Yeah, there's some.
Tony, that's right. James, Tom for a moment. James?
What's your name on?
Yeah, I've got